Today we're going to be talking about solving polynomials. So this is part 2. And so let's go over a couple things to recall first. The solutions of a polynomial are its x-intercepts. So when we're finding the solutions, the answers of a polynomial, it's always going to represent our x-intercepts. We can also call x-intercepts roots, zeros, or solutions. That's just another way to say x-intercepts. Graphically, solutions can be found easily by looking at your x-intercepts. So when you're looking at a graph, you look at the x-intercepts, those are the solutions, and can be written as linear factors of the polynomial. If x equals b is an x-intercept, then x minus b is a linear factor, okay? And we're going to think about this. So let's say x equals 5, and that was your x-intercept. Then we would write x minus 5 as a linear factor, and the reason is because when we set this equal to 0, so x minus 5 equals 0, we would add 5 to both sides, and x would equal 5, and that would be your x-intercept. So that's why we do the opposite when we write a linear factor. We take the opposite of whatever b is here, so that when we set it equal to 0, we're gonna add or subtract, right? We're gonna do the opposite to bring it to the other side, and we'll get the x-intercept here. So algebraically, we attempt to factor a polynomial into linear factors to determine the solutions. When solving polynomials algebraically, set the equation equal to 0. All right, so we're going to go over 2 examples here. So remember, it needs to equal 0. So this one equals 0, that's good. This one doesn't, so we have to move the 22 over. So we're going to subtract 22 from both sides, and then we have x squared minus 9x minus 22 equals 0. And then we have to find the factors of negative 22. Okay, so here's all the factors. We have to decide what adds up to negative 9. So 2 minus 11 is negative 9. So then it's x plus 2, x minus 11. Now, these are called the linear factors, and I'm going to explain this in a second. So here we go, x plus 2, x minus 11, and then we're going to set each of these equal to 0. So x plus 2 equals 0, or x minus 11 equals 0. And then we're going to solve, and when we subtract 2, we get negative 2. When we add 11, we get positive 11. Now, these are called the x-intercepts, right? That's what we just found. The x-intercepts, the solutions of a polynomial are its x-intercepts, or root zeros solutions. Okay, all of those can be said about x equals negative 2 and x equals 11. But remember when we were talking about the linear factor. So if I wanted to write these back as linear factors, I would write x plus 2, because it's always the opposite, and that's what we had up here. So this is called a linear factor. This is also a linear factor, x minus 11. When we solve, we get a positive 11, but when we plug it back into the negative factor, or to the linear factor, it's x minus 11. So hopefully that makes sense. That's what we're talking about for this second point right here. Okay, for number 2, it's already equal to 0, but we always check for a GCF. So when we looked here, if there's a 1 in front of the x squared, there's no GCF unless there's an x, but all of them have to have an x, and they don't, so there's no GCF here. On this one, all of them we can divide each of them by negative 4, and they have an x in common as well. So we're going to look at the GCF first. We have to pull that out, and then we're going to divide each of these terms by negative 4x, and we're going to write our answer in here. So if we divide the first term by negative 4x, we get a positive 1x squared, and so on and so forth. Negative 28 divided by negative 4 is a positive 7. X squared divided by x. Remember, we just subtract. So 2 minus 1 is 1. So we just have a 7x. And negative 24x divided by negative 4x is a positive 6. The x's cancel there. Okay, now here this can actually be factored. And you can write it out like this. Okay, but in this case, I'm just going to tell you it's x plus 6 and x plus 1, but you'd factor it again, a times c, which is 6, and then the 2 numbers that multiply to 6 and add to 7 are 6 and 1. So we're going to write x plus 6 and x plus 1. We're going to bring down that 4x, and we're going to set it equal to 0. And now, if you want to, wrap parentheses around the negative 4x, because we need to set this equal to 0, this equal to 0, and this equal to 0. So when you have a GCF, you have to set that piece equal to 0 as well. So we're going to have 3 answers this time. X equals 0, x equals negative 6, and x equals negative 1. Okay, so the fundamental theorem of algebra. Every polynomial of a degree n, with n is greater than or equal to 1, has exactly n linear, real or complex factors, thus n solutions. Okay, this might sound really confusing. Let's plug in like a number for n. So let's say every polynomial of a degree 3, okay, 3 is greater than or equal to 1. 3 is greater than 1, so that makes sense. So let's say it has a degree of 3. It has exactly 3 linear, real, or complex factors, thus 3 solutions. So what this means is when you have a degree, whatever your highest degree is the degree of the term, right? Or the degree of the whole polynomial, right? So if we have x cubed, for example, and that's our greatest degree, that means we're going to have 3 solutions. If we have x to the 4th, and that's our greatest degree in the polynomial, we're going to have 4 solutions. Okay, so that's all that means. Now, it also says real or complex. We have not talked about complex, so I left this in the definition, okay, because that's the fundamental theorem of algebra, but we're not going to go over the complex factors because we obviously have not done complex numbers. That's with the I. So some of you have done those and some of you haven't. So again, this goes with complex and irrational solutions theorem. So complex and irrational solutions occur in conjugate pairs, and this is what this means. Like I said, I skipped out on, there we go. I skipped out on the I. I actually still have it here. I didn't mean to still have it here, but this I'm not going to talk about because we didn't talk about the, not everyone went over that lesson, okay? But if we have, let's say, x equals, so let's say one of our solutions to our polynomial is 3 minus the square root of 2. If that's a solution, automatically x equals 3 plus the square root of 2 is also a solution, okay? So same thing here. If x equals the square root of 5 and we get that as a solution, automatically the pair, the conjugate pair is x equals negative square root of 5. So whatever your square root is, one's going to be a positive and one's going to be a negative. If you get a positive square root of 5 here, you also have a negative square root of 5. Okay, so for irrational solutions, you're going to have a plus square root of b and a minus square root of b, just like here, a minus square root of b and a plus square root of b. In this case, it's just square root of b and minus square root of b. Okay, so that square root of b part, you're going to have a positive and a negative solution. Okay, so let's go over a few examples here. So it says determine how many solutions there are. Now remember, this is not in standard form. Standard form means your highest degree goes first. So to determine the degree of this polynomial, we're going to look at all our exponents. So we have a 7, a 2, an 11, and this is a 1. Our greatest exponent is the degree of the polynomial. So we have 11. How many solutions are there going to be? 11. Okay, same thing here. This is negative x to the first power and then x to the third power, right? So the 3 is greatest, so that's how many solutions there's going to be. Okay, now in this case, this is all the linear pairs put together, and we could multiply it all out, but there's no reason to do that. If we're going to multiply x times x times x times x, there's going to be x to the 4th. That's going to be our degree. So our greatest degree is 4, which means there's going to be 4 solutions here. Now for number 4, if you are just told the solutions, like the solutions negative 5, 0, 1, 8, and 6, how many solutions do you have? You have 5. So you're going to have 5 solutions, right? Okay. And then let's talk about here with the multiplicity. So if we have a 0, one of our zeros is 7 with a multiplicity of 3. One of our zeros is negative 1 with a multiplicity of 6, and then we just have a 0 of 3. Well, if we have a multiplicity of 3, here's 3, 6, that's 9, and then 10. Since this doesn't have a multiplicity, it's just a 3. That's just a 0 all by itself with no multiplicity, so 6, 7, 8, 9, 10. Okay, so consider, we're going to solve 2x cubed plus x squared plus 1 equals 0. Now this one, no factoring technique works. Why? Because we don't have an x squared, we have an x cubed, right? Doesn't it usually go 2x squared plus x plus 1 equals 0, right? Or 2x to the 4th plus x squared plus 1 equals 0. If you have an x cubed and then you have a squared and then you don't have anything else and it's just an x, we can't factor this with a normal factoring technique like ABC. So we have to do something called the rational root theorem. So any polynomial has possible rational roots. And the possible rational roots are going to be written as this ratio, the factors of the constant over the factors of the leading coefficient. Okay, now, let's say here, so we're looking back up at this example, right? We're solving this. So your constant is 1. The constant is the number without the x, right? Your constant is 1. What is the factors? 1 and negative 1. Okay, remember we're trying to find the factors of the constant and the factors of the leading coefficient. The leading coefficient here is 2. It's the number in front of your greatest degree. So that 2, the leading coefficient is 2. What are the factors of 2? 1, 2, negative 1, and negative 2. Don't forget that every number can have a positive and a negative factor. Okay, so if you have a constant of 1, 1 and negative 1 are the factors, and 2, 1 and 2 are the factors, but also negative 1 and negative 2. Okay, so let's make a list here. Well, remember we put the factors of the constant on top. So I'm going to put a 1, 1, 1, 1. And the reason I put 4 1s is because I have 4 leading coefficients that I'm going to put on the bottom. So I'm going to put a 1, a 2, a negative 1, and a negative 2 here. Okay. And then here we go with the next one. I'm going to look at my constant of negative 1. I'm going to put negative 1 all the way across the board. And then I'm going to put my leading coefficients on the bottom. Remember, this is what we're doing up here. It's the factor of a constant over the factors of the leading coefficient. So 1 over 1, 1 over 2, 1 over negative 1, and 1 over negative 2. And then we're going to go negative 1 over 1, negative 1 over 2, negative 1 over negative 1, and negative 1 over negative 2. Whew, that's a lot. Okay, so these are your 4 possible solutions. The reason there's only 4 out of there's 8 here, right? But we can simplify this. Like 1 over 1 is 1, right? Okay, well, we also have 1/2 here, and we also have 1/2 here, because a negative over negative is positive. We have a negative 1/2 here, and we have a negative 1/2 here, right? And then negative 1 over 1 is 1, which is here, 1. 1 over negative 1, when you divide that, it's negative 1, and negative 1 divided by 1 is a negative 1 as well. So if you simplify all of these, we actually only have 4 possible solutions. So then we're going to have to check what is a solution by using synthetic division. So instead of using the 1/2 and the negative 1/2 right now, I'm going to try negative 1 and 1. So again, remember, I start with the original equation that I had here. And remember, we always have to go in order. And if there's no x term here, we have to put a 0 in for that term right there. Okay, so we're going to try negative 1 first. So we're going to bring down that 2, and then 2 times negative 1 is negative 2, add down. So 1 minus 2 is negative 1. Negative 1 times negative 1 is 1, add down. 1 times negative 1 is negative 1. That cancels out. So in this case, since r is 0, we have a 0 remainder. X equals negative 1 is a solution. Okay, now for this one, we're going to try a 1. So I'm going to bring down that 2, and then I'm going to do the same thing. I'm going to use synthetic division. Since here we got a 4, our remainder does not equal 0. X equals 1 is not a solution. Okay? All right, so now if we look at this, if I tell you here, we're going to list the possible solutions first, and then we're going to determine if negative 2 is a solution. So if we list the possible solutions here, we have to look at our constant. So our constant is 26, negative 26, I'm sorry. And so we have to look at all the factors of negative 26. So 1 times 26, 2 times 13, and each one get a positive and a negative factor. And then we also have a leading coefficient. Our leading coefficient is 2 because our greatest degree is 4. So our leading coefficient is the number in front of the greatest degree. So 2, and then we have our factors are only 1 times 2 and negative 1 times negative 2. Okay, now we have to list them all out by writing them as fractions, right? And don't forget, it's the factors of the constant over the factors of the leading coefficient. So this is the list that we get. Now this is why. Okay, 1 over 1, right? And we get a plus and minus for all of them. So 1 over 1, and then we have 1 over 2, and then we have 2 over 1, which is here. 2 divided by 1 is 2. 2 divided by 2 is 1 again, so we don't have to write that again. 13 divided by 1 is 13. 13 divided by 2 is 13 over 2. 26 divided by 1 is 26, and 26 divided by 2 is 13, so we don't have to write that one again. So if they repeat, don't write them twice. Okay, this is our list. Now, we would hate to have to check all of these, right? And there's going to be 4 solutions here. We would hate to have to check all of these. So in this case, it just says determine if negative 2 is a solution. And negative 2 was one of our possible solutions. So we're going to use synthetic division here. Okay, so I just rewrote the problem here, and I'm going to use synthetic division by bringing all the numbers in front of the all the coefficients and the constant. I'm going to bring those down. It goes in from greatest to least, 4, 3, 2, 1, 0, so we don't need to add any filler zeros here. And then we just solve. Now when we solve, we get a 12 here, right? So that means that x equals negative 2 is not a solution. And that's all you have to do when it just says determine if it is a solution. You don't have to check the rest of them.